Chae, and I am the presenter of the study designing an experiment to measure alert fatigue of different alarm sounds using the physiological signals. I am graduate research assistant in Yonsei University from South Korea. These are the content. I'm going to start with the introduction, and it will lead to the definition of alert fatigue. And I'm going to talk about the research hypothesis and the methodology. And finally, I'm going to present the experiment design and expected finding of the design. Thanks to the Center for Construction Research and Training Data Bulletin in February 2021, we can see in the graph that stroke by accident is one leading cause of fatal injuries in construction site. And stroke by an accident is one major cause of stroke by accident is a blind spot. As you can see in the top three features, the blind spot is a serious problem for construction equipment or the construction vehicle. The operator or the driver of such vehicle or equipment cannot see their surroundings well. Many alarm systems is developed to prevent the stroke by accident. Like this research, they developed two 4D models to reduce the false alarm for stroke by accident hazard preventions. These kind of alarm system research, they are focusing on developing more accurate and fast alarm systems. But even though the alarm system get accurate and fast and the rate of false alarm is reduced, but due to the dynamic status or the dynamic circumstance of construction industry, the close proximity working is inevitable, and therefore it will lead to the frequent alarm. And frequent alarm is inevitable even though the alarm system gets more accurate and more fast. Then frequent alarm, and why the frequent alarm is important is that frequent alarm can lead to alert fatigue, the main idea of this research. Alert fatigue is the phenomenon of individual or group constantly exposed to frequent alarm and become desensitized towards the alarm. Then you may wonder that why the alert fatigue is important. Alert fatigue is important because alert fatigue is desensitization towards the alarm. It can lead to the lower alertness toward the alarm, and it can lead to the slower reactions. And slower reaction to the alarm can relate it with the equipment-related accident or the stroke by accident. As I said before in the previous slide, due to the dynamic circumstance of construction site, the frequent alarm is inevitable. So to manage the alert fatigue, we hypothesize that maybe the alert fatigue is different by an alarm sounds, and we can find the most effective alarm sound to manage the alert fatigue. And our second hypothesis is that maybe the physiological signals can be useful to measure the alert fatigue. You can see in the bottom figures, every different alarm sound relates to every different amount of alert fatigue. And we can measure such different alert fatigue with the physiological signals. So our main objective is that to designing an experiment to test this hypothesis and finding the most effective alarm sounds that can prevent the stroke by accident. We're gonna use the three different alarm sounds. The first one is a complex tone, which is represent the conventional alarm, like a beep sound. Complex tone is a multiple sinusoidal component of different frequencies. In this study, we're going to use a 500, 10,000, 2,000, and the 3,000 hertz sound. Second one is an auditory icons. We suggest this icon. We suggest these alarm sounds. Auditory icon is a sound that occurs in a threat or hazard situations, such as tire skidding sound in the driving situations. Cell-phone name is a third alarm, and cell phone name is a sound of subject calling him or herself by their own name. The mechanism behind the alarm sound is like this. Complex tone or conventional alarms, they need the identification process to be alerted, because the beep sound itself did not mean the dangers. We need to identify the beep sound as a danger alarm. but as auditory icon has already information about the hazard or the threat, and the cell phone name can occur the alert to the subject, alert of the subject by its nature, because like it's our name. When we heard it, we know that someone is calling me and our body is alerted. That's the mechanism behind the alarm sounds. But you may wonder that is the recognition performance of auditory icon and cell phone name is in the same dimension with the alert fatigue prevention performance. That's why we're adding another alarm system, which is a mixture. Mixture is a suggested sound system that the suggested sounds such as auditory icon and the cell phone name will occur in random order. Mixture alarm is suggested because it can prevent the desensitization due to the monotonous alarm system, alarm sound. Well, as I said in the previous slide, that the definition of alert fatigue is a desensitization towards the alarm sound due to the frequent alarm. Maybe the mixture alarm can help to prevent the alert fatigue. For measuring the alert fatigue, we're going to measure the alertness of the subject. We're going to measure it with the physiological signals. We're going to use the electroencephalography, event-related potential, and the electrodermal activity. The electroencephalography and the event-related potential is physiological signals that related to the brains and neurons. They track they measure the electric from the scalp surface, and they represent the activation of the neurons. Electrodermal activity is a skin conductance signal obtained from the skin surface. The signal represent the activation of autonomic nervous systems, which is specifically related to the alertness. So if the alarm sound occur and we heard it, then our body will be alerted. And we can measure such alertness by the physiological signal or physiological data. And also, when you heard the alarm, we usually react, and we can measure the reaction time and label the data as a behavioral data. We can compare the physiological data to the behavioral data, and we can verify our second hypothesis, which is that the physiological signal can measure the alert fatigue. Our experiment design is like this. We want to simulate the equipment operator's action in the laboratory. The subject will wear the physiological sensors, which is a red arc and the red strip in the wrist. They will play the game. The game is presented in the upper right corner, which we made with the Unreal Engine 4. The game is, the purpose of game is to give circumstance to the subject that they are the equipment operators. And while they're playing games, the auditory stimulus will be presented, which is the alarm sound I just mentioned. When they heard the alarm sounds, they were gonna press the target reactions, which is a brake pedal located in front of their foot. And we can measure the reaction time from the target, from the brake pedal. And for the data processing, we're gonna collect the physiological data before the alarm, like 5 seconds, and after the alarm, like 5 seconds. And we can compare the physiological data, which is alertness before the alarm and alertness after the alarm, and compare it, and we can get the alertness change. And as a tendency of alertness change to the time means the alert fatigue. If the alertness decrease as the time passes, it means the alert fatigue is present, exists. And we can compare it with the tendency of reaction time. And if the reaction times become slower and the alertness become decreased as the time passes, then we can say that the alert, we find the alert fatigue, and physiological signal can measure the alert fatigue. And by comparing the alert fatigue of complex tone and our series suggested alarms, we can expect it to find that suggested alarm will perform better than the conventional alarm. And second, we expect to find that physiological signals can successfully measure the alert fatigue. Our expected contribution is that finding an effective alarm sound can control the alert fatigue and relate it to reducing the struck by accident. And we can test the feasibility of measuring alert fatigue by physiological signals. Our limitation is that simulation is maybe not enough to reproduce the circumstance. And finally, we need to go to the real construction site. Thank you for listening.
Thank you, Youngcheol. This is a wonderful topic. I can just refer to some of our own work, and audio plays a major role in experiencing how we perceive reality.